March 15th, 1945. The Rhine Crossings. Feldwebel Werner Kempf crouched in his Panther tank, scanning the horizon through his commander's cupola. For 3 years, he'd faced enemy armor from Poland to France to Russia, and he knew the drill. German tanks dominated at range, their superior optics and powerful guns picking off inferior Allied machines before they could close the distance. The Americans had numbers, certainly, but everyone knew their Shermans were death traps, burning easily, their crews calling them Ronsons after the lighter that promised to light every time. What Kempf couldn't see, what no German tank commander truly understood until it was far too late, was that inside each of those approaching Shermans sat a technological marvel that would render every tactical advantage of German armor irrelevant. A small metal box that transformed warfare itself. The SCR-528 radio. To American tankers, it was simply standard equipment, as unremarkable as their periscopes or machine guns. Every Sherman carried one, along with the SCR-508 for longer-range communications, creating an electronic nervous system that connected individual tanks to platoons, platoons to companies, companies to battalions, and battalions all the way up to Corps headquarters. Tank commanders could speak clearly to each other at ranges of 5 miles, could coordinate with infantry units carrying the SCR-300 backpack radios, could call in artillery strikes with pinpoint accuracy, could summon air support that would arrive within minutes. The radio operated on FM frequencies, crystal clear even while moving at full speed across rough terrain. A far cry from the static-filled AM sets that equipped most German tanks, when they had radios at all. Lieutenant Colonel Creighton Abrams, commanding the 37th Tank Battalion, would later describe the moment he first realized the true implications of this disparity. His unit had engaged a superior force of Panthers near Cologne, tanks that outgunned his Shermans by every traditional metric. The Panther's 75mm high-velocity guns could penetrate a Sherman's frontal armor at 2,000 meters. The Sherman's 75mm guns struggled to penetrate a Panther's front even at point-blank range. But Abrams had something the Germans didn't: instantaneous communication with every tank in his battalion, with the artillery batteries 10 miles behind him, with the P-47 Thunderbolts circling overhead. Within 90 seconds of first contact, he had coordinated a 3-pronged assault, his tanks maneuvering in perfect synchronization to flank the Panthers, artillery rounds landing precisely where he directed them, and fighter bombers diving on positions he marked with smoke. The German tanks, magnificent in their engineering, fought as individual knights in an age of systems warfare. The disparity went deeper than most German crews ever realized. By 1944, the United States was producing 20,000 radios per month, not per year, per month. The Signal Corps had standardized production across dozens of manufacturers. Motorola, General Electric, RCA, Bendix, all churning out identical units with interchangeable parts. A damaged radio could be repaired in minutes with components from any other set. The crystals that controlled the frequencies were mass-produced in climate-controlled factories, each one tested to maintain accuracy within 0.01%. The entire system was engineered for reliability. The sets were waterproofed, shock-mounted, and tested to operate in temperatures from -40 to +120 degrees Fahrenheit. They worked in the dust of North Africa, the mud of Italy, the snow of the Ardennes, without modification or special maintenance. Meanwhile, Panzer Regiment II, one of Germany's elite armored units, submitted a report in January 1945 that revealed the true state of German tank communications. Of their 45 operational tanks, only 12 had functioning radios. The rest relied on signal flags, hand gestures, or following the lead tank, methods little changed from the First World War. Even when German tanks possessed radios, they were typically the FUG-5, an AM set prone to interference, with a range of less than 2 miles when moving. Only platoon leaders and company commanders rated radio equipment. Individual tank commanders were expected to maintain visual contact with their leaders, an impossibility in the smoke and confusion of battle. The sophisticated German optical equipment, the superb armor, the devastating guns. All of it was shackled to a communication system that Napoleon would have recognized. The Americans didn't just have radios. They had an entire doctrine built around them. At Fort Knox, the Armored Force School trained every single tank crew member in radio operation, not just the commanders. They learned proper radio discipline, how to keep messages brief and clear, how to use the phonetic alphabet, how to switch frequencies under fire. They practiced radio silence drills and emergency net procedures. Every graduate left knowing not just how to use the radio, but how to think in terms of networked warfare. The training materials emphasized what they called command push, the ability for higher headquarters to instantly transmit orders to every unit simultaneously, collapsing the time between decision and action from hours to seconds. The technical specifications alone told a story of two different worlds. The SCR-528 featured 18 preset channels that could be changed instantly with the flip of a switch, allowing units to shift to alternate frequencies if they encountered jamming or interference. The radio drew its power from the tank's electrical system through a dynamotor that provided stable voltage regardless of engine speed. The antenna system was a marvel of engineering, a series of matched sections that could be assembled in different configurations depending on terrain and range requirements. The Americans had even developed special antenna parks where replacement sections were stored pre-tuned and ready for immediate installation. German tank radios, when they worked at all, typically operated on a single frequency that required manual tuning, a process that could take minutes while under fire. Captain James Leach of the 3rd Armored Division documented an engagement near Paderborn that exemplified this revolution. His company of 17 Shermans encountered a German blocking position defended by 6 Tiger tanks, theoretically an impossible matchup. But Leach was in constant communication with a forward observer from the 54th Armored Field Artillery Battalion, who was himself connected to 3 batteries of 105mm howitzers. As Leach's tanks advanced, he called out targets using a simple grid reference system. Concentration Alpha, drop 5-0, fire for effect. And within 40 seconds, 72 rounds of high explosive would blanket the position. The Tigers, unable to coordinate their response, unable to call for their own artillery support, unable even to warn each other of flanking movements, were reduced to fighting isolated duels against an integrated weapons system. 4 Tigers were destroyed, 2 abandoned. Leach lost 1 Sherman to mechanical failure. The production statistics revealed an industrial mismatch that went beyond simple numbers. American factories didn't just produce radios. They produced complete communication ecosystems. For every tank radio manufactured, 10 additional units were built for support vehicles, repair shops, and command posts. The Signal Corps established a global supply chain that could deliver a replacement radio tube from a factory in Chicago to a tank in Germany in less than 2 weeks. They printed millions of frequency allocation cards, laminated and sized to fit in a tank commander's pocket. They manufactured specialized testing equipment that could diagnose radio problems in seconds. They even produced waterproof bags for storing code books and frequency lists, each one individually numbered and tracked. This attention to detail, multiplied across thousands of components and millions of units, created a communication advantage that no amount of German tactical skill could overcome. Technical Sergeant Michael Kozlowski, a radio operator with the 4th Armored Division, kept a diary that captured the day-to-day reality of this technological superiority. On March 22, 1945, his entry described a running battle through the German countryside where his tank platoon never actually saw most of the enemies they destroyed. Reconnaissance aircraft spotted German vehicles withdrawing along parallel roads and radioed their positions to Kozlowski's platoon leader. The tanks would advance to a ridgeline, fire several rounds at coordinates they'd been given, then move to the next position before German artillery could respond. At one point, Kozlowski's tank threw a track. Within 3 minutes, he had radioed for maintenance support. received confirmation that a repair team was en route, and arranged for another tank to cover their position. The entire exchange took less time than it would have taken a German courier to find his company commander. The radio advantage extended beyond tank-to-tank communication. American armor could talk to infantry squads, to reconnaissance aircraft, to supply trucks bringing fuel and ammunition. A damaged Sherman could radio for maintenance support and have a repair crew on site within an hour. A battalion running low on fuel could coordinate with quartermaster units to arrange resupply at a specific map coordinate. This integration was so complete that American units developed what they called hip shoots, engaging targets spotted by reconnaissance aircraft without ever seeing them directly, the pilots talking the tank gunners onto targets hidden behind hills or buildings. The Germans, watching shells land with impossible accuracy on positions that should have been invisible, attributed it to superior American reconnaissance or spy networks. They never realized it was simply a forward air controller with a radio and a map. The contrast became even starker in the realm of maintenance and repair. American radio technicians were embedded at the company level, trained not just to fix radios but to modify them for specific missions. They carried spare parts inventories that would have seemed fantastical to their German counterparts. Dozens of tubes, hundreds of capacitors and resistors, miles of wire, spare crystals for every possible frequency. They had specialized tools designed specifically for tank radio repair, miniaturized soldering irons that could work in confined spaces, tube testers that could diagnose problems in seconds, even tiny vacuum cleaners for removing dust from sensitive components. When Staff Sergeant Jerome Patterson's radio repair truck was captured intact near Remagen, the German signal officers who examined it couldn't believe what they found. The truck contained enough spare parts to repair 100 radios, detailed circuit diagrams for every American radio model, and a complete machine shop for fabricating custom components. It was, one German officer wrote, like capturing a piece of the future. The production statistics told the real story. In 1944 alone, American factories produced 57,000 tank radios. German production for the same period, 2,800. But the raw numbers only hinted at the deeper disparity. American radios were built on assembly lines using standardized components that could be sourced from multiple suppliers. If one factory was bombed or suffered a mechanical breakdown, others could immediately increase production to compensate. German radio production, concentrated in a handful of specialized facilities, never recovered from the bombing of the Telefunken works in Berlin. Even when they managed to produce radios, they often sat in warehouses for weeks, waiting for a specific type of tube or crystal that only one factory could make. Unteroffizier Hans Becker, a Panther commander captured near Frankfurt, told his interrogators something that perfectly captured the German tanker's bewilderment. He described engaging what he thought was a lone Sherman that had blundered into his sights. He fired, missed, and the Sherman disappeared behind a building. 30 seconds later, his tank was hit by artillery fire. As he bailed out, he saw 3 Shermans converging on his position from different directions. Until the Americans explained it to him in the POW cage, he believed he had driven into an elaborately prepared ambush. In reality, that lone Sherman had simply radioed his position, and every American unit within 5 miles had responded. Becker's war had been fought tank against tank. The Americans were fighting network against node. The psychological impact of this communication gap cannot be overstated. German tank crews operated in a state of permanent uncertainty, never knowing if support was available, if their flanks were secure, if their ammunition resupply was coming. They developed what psychologists would later term isolation paranoia, the constant fear that they had been abandoned, that their unit had been destroyed, that they were fighting alone. American tankers, by contrast, fought with the confidence that came from constant connection. They knew exactly where friendly units were located, could request help with the push of a button, could hear the voices of their comrades even in the chaos of battle. This psychological edge was as important as any technological advantage. The disparity became even more pronounced during the fluid battles of the German collapse. As Wehrmacht units disintegrated, American armored columns could advance at speeds that seemed impossible to German commanders. Task Force Wellborn of the 3rd Armored Division covered 90 miles in a single day during April 1945, navigating entirely by radio communications with reconnaissance elements that were sometimes 20 miles ahead of the main body. When they encountered resistance, they could coordinate attacks without stopping to hold map conferences or send couriers. The task force commander, riding in a Sherman equipped with both the standard tank radios and an additional SCR-506 for communication with division headquarters, could simultaneously direct his own units, request air support, coordinate with adjacent units, and report to higher command. He was fighting with perfect situational awareness while his opponents were fighting blind. The Germans tried to adapt. In late 1944, they began installing the Fuji-8 radio in more tanks, a better system but still inferior to American equipment and still limited to company commanders and above. They attempted to copy captured American radios, but lacked the industrial capacity to mass-produce the necessary components. The precision crystals, the miniaturized tubes, the standardized connectors, all required manufacturing capabilities that Germany's bombed and resource-starved industry couldn't provide. Even when they managed to produce improved radios, there was no training system to teach their use, no maintenance network to keep them running, no doctrine to exploit their capabilities. They were trying to graft a nervous system onto an organism that had evolved without one. The final months of the war saw increasingly desperate German attempts to compensate for their communication disadvantage. They tried using motorcycle couriers to relay messages between tanks, but the riders were easy targets for American fighters. They experimented with colored smoke signals, but these only revealed their positions to enemy artillery observers. Some units attempted to maintain communication by stringing telephone wire between tanks, a solution that would have been laughable if it weren't so tragic. Meanwhile, American radio technology continued to evolve. By April 1945, some American units were experimenting with early VHF sets that offered even clearer communication at longer ranges. They were developing frequency hopping techniques to defeat jamming, encrypted voice systems to prevent eavesdropping, and portable repeater stations to extend range even further. The Germans were fighting the last war while the Americans were already preparing for the next one. Master Sergeant Roy Duggan, a tank commander in the 2nd Armored Division, would later reflect on a truth that German tankers learned too late. The war wasn't won by the tank with the thickest armor or the biggest gun, but by the crew that could call for help. In the hedgerows of Normandy, the plains of Lorraine, the forests of the Ardennes, and the final drive into Germany, American tanks fought not as individual vehicles, but as nodes in a vast communication network that stretched from the forward edge of battle back to the Pentagon itself. Every Sherman crew member knew that behind their thin armor and modest guns stood the entire weight of American industrial and military power, instantly accessible through the microphone hanging next to the commander's position. The numbers were staggering in their finality. By war's end, the United States had produced over 200,000 military radios of all types. They had trained 300,000 radio operators. They had established a global communication network that could relay a message from a frontline tank to Washington, D.C. in minutes. The infrastructure they built, the repair facilities, the supply chains, the training programs, represented an investment in communication technology that dwarfed the entire German tank production program. While German engineers obsessed over achieving the perfect balance of armor, firepower, and mobility in tanks that would be built in the hundreds, American planners had recognized that warfare had become a problem of information management, and they had solved it with characteristic thoroughness. The Sherman tank has been endlessly criticized by historians and veterans alike. Its armor was too thin, its gun too weak, its gasoline engine too flammable. All true, but inside each Sherman sat equipment that transformed it from an individual fighting vehicle into part of something larger, a thinking, communicating organism that could sense threats, coordinate responses, and mass firepower with a speed and precision that rendered traditional tank tactics obsolete. The German tankers, magnificent in their skill, courageous in their determination, never understood that they were fighting the last war, while their enemies had already moved on to the next one. They died, too often, waiting for orders that never came, scanning for enemies they couldn't see, calling for support that couldn't hear them. They died in the finest tanks ever built, defeated by radios they never knew existed.